Very good morning, students. So, welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the participant branches so far, along with your class 7th students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Our ongoing chapter, circular motion. And today we are entering into the session number 3. So far, we completed 2 sessions to understand a special type of motion called circular motion. And we continue where we left in the last class. But before that, let us recall what we learned about the circular motion so far. So as you all know that circular motion is a special type of motion. So there are so many types of motions we have seen in the first chapter only. Among that, circular motion is the one important one. Why? Because when a body is moving along the straight line, some kind of force acts on it continuously to make the body to follow a curved path. So that plays very important role in our even day-to-day applications also. In our day-to-day applications, we'll see so many examples for the circular motion, right? So when a body is in circular motion, the commonly used terms, when a body is in linear motion, we have seen when a body is in linear motion, we see that body has covered distance, displacement, speed, velocity, acceleration, deceleration, all these things. Similarly, in circular motion also, every body will possess these terms. But terms are named differently. They are named as angular displacement, angular velocity, angular acceleration. Because when a body follows the curved path, circular path, along a radius, it makes some angle with the origin. So that is the reason angular will come. So what we discussed in the last class, all the terminology related to circular motion of a body, right? Then after knowing about the terms, you can see here, what is uniform circular motion? A body moves with a constant speed, like Earth is moving around the sun, or all the planets are moving around the sun with constant speed. They are said to be in uniform motion. Electrons revolving around the nucleus continuously with a constant speed called uniform circular motion. Then consider terms. What is radius vector, angular displacement, angular velocity, angular acceleration, right? And finally, all these things are possible only when force is acts on a body, right? When some kind of force which is responsible for body to move in a circular path. If the force is not acting, either body may be at rest or body may be moving in the linear direction as per the Newton's first law of motion. But what is happening here? There is some force acting on a body and changing its direction time to time. Changing its direction time to time. Due to changing the direction, it follows the path called a circular motion. So that forces we discussed, introduced in the last class. That is, there are 2 kinds of forces. There are 2 kinds of forces acting on a body which is in circular motion. The first one is called centripetal force. Second one is called centrifugal force. Right? So little bit more we'll discuss about these 2 forces and we'll see what are the applications. What are the applications of these forces in our regular life? Right? So as you already learned, Centripetal force is the force which is responsible, for example, if your body is in circular motion, right? So this is a radius. First body is at OA, right? At OA. When you are applying a force here, some force is acting on the body and makes the body to move along the circular path. So this force is called centripetal force, which is responsible for making the body to move along the circular path. Then that is always acts towards the center. It acts towards the center and makes the body to move. But why, when the force is acting towards center, why the body is not coming close to the center? When a force is acting on a body, the body should move towards the center. It is not moving. That means there is another kind of force acts away from the center. The same magnitude. Then that means why Earth is not falling into sun? Why electron is not collapsing into nucleus? That is because there may be some force. There may be some force which is acting away from the nucleus or away from the sun to make the body to move, remains the same orbit. That is, we cannot see that because it is not a real force, but there is a force is there. Because of that, the body remains the same orbit. You have seen yesterday video also. When bucket full of water, when you are rotating, at the highest point, bucket is reversed, but no single drop of water fall down as long as you are continue to rotate. That means there should be some force acting away from the center on the bucket of water. That force is called centrifugal force. So one force acts towards the center and allows the body to follow a circular path. And second force is an imaginary force which acts away from the center. And both forces, when the two forces acts on the same body with same magnitude, what happened? Body remains at same position. And both are in same magnitude. That magnitude is given by mv square by r formula. Already we derived yesterday. You have seen. So mass into acceleration, mass into angular acceleration. So mv square by r, or you can write mr omega square also in terms of angular velocity. Because v is equal to r omega. In last class we have seen the relation between linear velocity, angular velocity. So these are the two important forces which are responsible for a body to move in a circular path and stay on the same orbit without falling into center. Such a kind of forces are centripetal and centrifugal. Right? So these are the two forces which are very much responsible for body to move in a circular path and body to remain in the circular path. So both are important. Not only moving is important, remaining also important. Okay. So here clearly explained about the. So this centripetal force is called center seeking force, which always acts towards the center. Center seeking force. Okay. Whereas centrifugal force, which acts away from the center, is called center fleeing force. Centripetal force is a real force, whereas centrifugal force is a pseudo force, imaginary force, fictitious force. Very, very, very important. Right? The differences are very important. Every body, when a body moves around circular path, it may be, see for example, to see washing machine, how the clothes are dried. You know, when washing machine, there is a dryer is there, right? So clothes are dried, not dyed, dried. How they are dried? They are dried because of the centrifugal force only. Why? Because when the clothes are washed, after washing, if you observe carefully in the washing machine, there are some holes will be there to the tub. There are some holes will be there. After washing the clothes, when the clothes will be, because as it is moving, the wheel is moving, the clothes are stuck to the wall. The clothes are thrown and struck to the wall. When they are stuck into the wall, water present in them will come out of the holes and it comes through pipe. Like that, the water is separated from the wet clothes because of centrifugal force. By passing current, we are having the centripetal force. But during that rotation of the wheel, either it is a top load or bottom load, no problem, side load also. Because of the rotation, the wet clothes are stuck to the walls of the washing machine, where the water is separated from the wet cloth. When water is separated from wet cloth, what happened? Clothes will be dried. Just like how you are squeezing the water, like that happened inside the washing machine because of centrifugal force. Like that, there are so many examples. Okay, so first I'll show you one video before giving the examples for you. Watch the video, then we can go for the explanation of the or applications of the forces, right? Just watch the video first.
Hello friends, let's see an interesting activity. Why is the nut coming to the center? Because of centripetal force, right? Hi, this is Meena Natsunkar. I just gave a small demo of how I started session in my class. Here, I performed this activity to get your attention.
Just one more video. It's already we have seen last class.
Have you ever wondered why spinning really fast on a merry-go-round pulls you towards the edge and makes you fly off, while spinning really fast around the Earth creates gravity and keeps you from falling off? It's because there are actually two different forces at work here. The merry-go-round effect is caused by centrifugal force, which repels things from the center, while gravity is instead related to centripetal force, which draws things towards the center. This is not a lesson on physics, we promise. It's a lesson on human geography. So why are we talking about Newtonian ideas? Some geographers realized that just as different forces can pull things apart or push them together, this is also true of geopolitics, or the relationship between people, politics, and physical space. Some things help unite a country, centripetal forces, while other forces pull it apart, centrifugal forces. The implication is that if you want your country to stay united, the centripetal forces have to be stronger than the centrifugal forces. Let's start by examining the centripetal forces of geopolitics, or the forces that help bring people together and create a unified country. So, how do you bring people together? One obvious answer is roads. Infrastructure is one simple way that centripetal force is developed within a country. By increasing the ability of people, products, and services to connect, countries are literally more tightly connected. India is an example of a modern nation that has been putting major efforts into bringing roads to its remotest villages in an effort to increase national unity. It's worth noting that a large number of countries in the world have a very Newtonian sense of this, in that they place the center of their country, the capital and largest city, right in the middle. The geographic center of the physical country is the most common place to find a national capital, because it's easier to connect it to the entire population. Centripetal forces can also include cultural factors, and in fact, these are some of the strongest elements in bringing a country together. In general, we're talking about national unity, or the creation and maintenance of a national identity. You see yourself as part of the nation, of the community within shared geopolitical borders. Historically,
Okay, anyway, it's not so clear. There is some. So, how we have seen the centripetal force or centrifugal force in washing machine. The first example is, so washing machine. The clothes are dried in washing machine because of these an imaginary centrifugal force. Okay. The second one, electrons. So electrons revolves around the nucleus, right? All of you know. Electrons revolves around the nucleus, but not coming close to the nucleus. Their electrostatic force between oppositely charged particles, electrons and protons, acts as a centripetal force. Right? One is towards the center, other is away from the center. So the force which acts away from the center balances the force acting towards the center with same magnitude. Because of that, electrons are continuously revolving around the nucleus without falling into nucleus. So if you imagine, if they fall into nucleus slowly, your height is 4 feet today. Tomorrow it becomes 3.9 because electrons are coming close. So after sometimes you disappear. But that is not happened till now, right? Nobody is becoming shorter. Then Earth or planets, you can see, planets around the sun. So when the planets are moving around the sun, gravitational force acts as a centripetal force, whereas the another force, which is away from the sun towards the planets, acts as a centrifugal force. Because of that, all planets are continuously moving around the same orbit some millions of years. Means this is also example for the centripetal and centrifugal forces. For example, already told, giant wheel. There are so many play in amusement parks. When you go to amusement parks, we can see different types of giant wheels. Some of maybe in this direction, some of maybe like this they move, or some of they may be roller coasters. Right? Wherever that such kind of motion is there, we can find the both centripetal and centrifugal. Already I told in the last class, when a person in the circus moving around the globe by his bike with a great speed, when he reaches the topmost point, it will be reversed. His head is down, but still he is not falling down because he is acted upon by the centrifugal force when he is applied the accelerator. But when he stopped the bike, brakes, means centripetal force is stopped, centrifugal won't be there, then it will fall down. So there are so many interesting factors about these forces in a circular motion, right? Then, churning of milk. We'll do the milk churning to get the cream, to separate the cream from the milk. So when you are churning like this, so cream will be separated. You observe carefully when your mother will do. When you churn, churners will be there, or maybe nowadays you are getting electric also. When the churning is taking place, we are applying the centripetal force with our hand. Then what happened? There is a centrifugal force acts on a milk and makes the cream to separate from the milk. Milk and cream are separated by the same force in our regular life. See how important this kind of force for us. Then, if you see the making a pot, you might have seen so many places and so many villages, or you might have seen in movies also. They give a shape to the pot or flower vase, but when the wheel is continuously rotating, the rotation of wheel, and because of that particular force acting on the wheel, you can give a shape to the vase or pot. That is even our cycle tires. When they are rotating, how they are rotated? Because when you apply our pedaling, as long as you are pedaling, applying the centripetal force, the wheel will be continuously in the motion. If not, if you stop pedaling, there won't be any centrifugal force, it will stop. So like that, there are innumerable number of examples which we can see in our day-to-day life about the centripetal and centrifugal. But thing is, centripetal force is applied by us. Suppose take one thread and tie a stone at the bottom and try to rotate with your finger. That finger is supplying centripetal force. But when you stop the centripetal force, the stone will fall down. But as long as you are rotating, whirling the stone will follow the perfect circular path. So, when a body is moving in a circular path with constant speed, as its direction changes from point to point, it will possess some acceleration, the normal acceleration. And in that case, we'll get the terminology, angular displacement, right? Angular velocity, angular acceleration, and finally, a forces acts on a body to make the body to move in a circular path and not to fall into the center are centripetal force and centrifugal forces. The most important forces in a right. You can see here. Some examples are given. You can note down also. So some more I'll add for this. There are only few are there. Right. You can see. First one. First see that carefully. I will give time for you. First one. Centripetal force is a force required to provide centripetal acceleration to the particle so that it moves in a circular path. So if a body want to move in circular path, there must be a force called centripetal force. It may be electrostatic force, it may be gravitational force, or it may be a muscular force. No matter. But it should be allow the body to move in a circular path. Next one. The centrifugal tendency of the particle in its acceleration is explained by assuming the centripetal force acting on it. It is only assumption. We can only experience. We cannot see this. We can experience that there is a as a washing machine. How the clothes are dried. Okay, the motor is moving, but clothes are dried because of the centrifugal force. Second one. At every instant, it is directed radially towards the center. Radially means along the radius. Acts towards the center. The force always acts towards the center. It is radially away from the center. Radially away from the center. Acts away from the center. Okay. One is acting towards the center. Other is acting away from the center. That is the reason they balances each other. It is a real force. It is a pseudo. Pseudo means imaginary, fictitious. We can call it a pseudo force. Right. It is a real force. It is a pseudo. Very important one. Suppose fourth point, if you see, you can write magnitude of force. Centripetal force is given by mv square by r or mr omega square. Same for this also. mv square by r or mr omega square, but opposite direction. So you can write a negative also. Right? Opposite direction. See how much interesting it is. So many things you can write about this. So many very important forces which are responsible for body to move in a circular path and body to continue in the same orbit. Continue in the same orbit. Without falling into the center. Without falling into center. So both have same magnitude, but direction is different. One is radially towards the center, other is radially. What is radially? Along the radius. They won't act here and there randomly. They act along the radius only. One is towards the center, makes the body to move. Other is away from the center, makes the body to balance. One is real force, we have to apply. Second one is come into play in nature. That is the only God's given force. We cannot see that force, only you can experience. So, for example, see, you make one round in school, circle, and your teacher is asking you to run around the circle. You are running for 2 minutes, 3 minutes, 4 minutes, 5 minutes. As long as you are running, nothing will happen. When you stop, what happened? You will be thrown at the center. You will be thrown. Why? Because some force acts on you and it pushes you in the middle. You won't fall down outside. Inside you will fall down. Because outside force will be disappeared. Right? So very important types of forces these two. We can write this. You can note down these 4 points in your notebook in a form of table. Centripetal force, centrifugal force. It is out of textbook question. That is its answer. The first, second, third, and lastly, fourth point is formula. Just note down. Centripetal force is a force required to provide the centripetal acceleration to a particle so that it moves in a circular path. Jogipet, Alwal, Gurimalka. Fourth point is given by F is equal to mv square by r or mr omega square. Already I told angular velocity is denoted by omega. So there are various applications of centripetal forces in our day-to-day life. Suppose grinding process also centrifugal force only. Either you are using grinder or mixer cum grinder, where we are making the batter, preparation of batter for idli, dosha. All these are possible because of the forces acted by the grinders. The blades will be there. They follows a circular path, and by the producing centripetal and centrifugal forces, drying of clothes also example, and so many churning of milk, separation of cream from the milk also example for the centripetal and centrifugal forces. Like that, you can observe so many forces you can identify in your day-to-day life, where you can see these types of forces, where you can experience these type of forces, and you can make one chart for that also, right? Because the next month we are getting the science exhibition. With your own creativity, you can use these forces to exhibit the things in the science exhibition, right? These are the very, very interesting science activity. Right? So when you move forward, there is another important thing is, so finally came to the solid examples that we can see the same formula using the formula for angular velocity, angular displacement. See, examples are given here. Few examples for the magnitude of centrifugal force, where it acts. So examples, if you see, during the motion of the planets around the sun, the planets experiences centrifugal force. Then in the revolving of electrons around the nucleus, what I already told. When a moving car takes sudden left turn, a man sitting in the blank back seat falls away to the right. So because some force acts on him and pushes in opposite direction. All these are the examples which comes under the centripetal and centrifugal forces. See the formula mv square by r. It also came from F is equal to ma. Right? Same formula, Newton's law only. F is equal to m into a is nothing but centripetal acceleration. Is given by v square by r. But v is equal to r omega as per the relation between linear and angular velocity. If you substitute in place of v r omega, we'll get F is equal to m into r omega whole square by r. So F is equal to m r omega what's going to be r square omega square by r cancel. So F mr omega square. Either you can write centripetal or centrifugal force as mv square by r or mr omega square. Omega is the angular velocity. By using that only, there are some examples are solved with the help of C. Right. We can see here C. So F is equal to mv square by r. So from that they solve the V. What is the value of V? He asked for V, which is 10 meters per second. Here they use the angular velocity. Omega is equal to pi by t. displacement by time. Displacement is nothing but angular displacement. Angular displacement is given by pi by t. So pi is given in some radians, 360 degrees. We can convert into 2 pi radians. So they're done. Right? So if time permits in the next class, because this is the syllabus for 7th monthly test is already completed. Some worksheets we'll do in the next class when we meet about this chapter, and then we'll move over the last chapter of this in the near when we meet next time, right? So these are the common examples given around the study exams, solid examples. So some examples also here given, you can see. Wonderful examples for the centripetal and centrifugal forces. The force of string on a ball being spur. Ball. A frictional force between the axial and the surface of rotation of automobile. The force back of seat pushing an astronaut into centrifuge. Again, centrifugal forces. Mud flying off tire. When tire is moving around the mud, how it fly off? Mud will come backside. Right? Why? Because of that force acted by the centrifugal. Children being pushed out of the roundabout. The force that dries the clothes in washing machine. These all are the applications in our day-to-day life. Or are used applications of the both forces in our regular life. So the total circular motion chapter deals with the a special kind of motion in our regular topic, that is circular. So one only. There are so many motions are there: oscillatory, vibratory, rectilinear. But out of this, circular motion plays separate thing because there are different types of force acts on it. So whenever force acts on it, there is a velocity, acceleration, displacement in different way, because direction is changing at every point. Okay. So this is your home task. Already you have written on table form. Once check it and add points if you get anything, and take the signature from your class teacher and parents. Differentiate between centripetal and centrifugal force. So with this, today we have completed this chapter with the conceptual explanation. But when we meet next class, we'll try to solve some solid examples and worksheets also, which is useful for our examination. So that's all for today. Thank you very much, all of you. Have a wonderful day. Thank you.